back to this channel, and we are looking at repeated eigenvalues of A, and then case 3. We've already discussed case 2, and case 2 is a case of when the eigenvalue repeated 2 times and it produces just one eigenvector, and I'll discuss that with questions. So if you have missed that video, please quickly go there now and watch it before you go to case 3. Case 3 is all about when the eigenvalue repeated 3 times. I mean, R1, R2, R3 are the same, but it produces just one eigenvector. In that case now, what do you do? So in that case, we find generalized eigenvector U2 and what? And the third eigenvector. Okay? And we have the step to be taken. So please, let's dive in and see what happened for repeated eigenvalue 3 times and what are the general solutions. If the eigenvalue repeated 3 times, but it produces one eigenvector. Okay, we find the generalized eigenvectors, which are this, the second eigenvector, and what? The third eigenvector. By solving and what? And U3 equal to the third eigenvector equal to the second eigenvector. So when we solve this one, we get the second eigenvector. When we solve this one, we get the third eigenvector. Okay? So therefore, we need to get the solution. The solution, the system, the solutions are, the first solution as a function of t will be equal to this, where your R is your eigenvalue. The second solution will be this one, and the third solution, these are all vector, the third solution will be equal to. So these are the solution, okay? Then the next thing is the general solution. The general solution is this one, okay, equal to C1 times this plus C2 times this plus what? C3 times x3 as a function of t. So these are the rudiments, these are the tools we need to solve the case of eigenvalue being repeated 3 times. Okay? And the best thing to do now is to look for questions. Okay? Let us practice questions. Okay? So let's dive in and see solution to questions. We have this question, solve the system. And then we have the vector derivative, okay, equal to this matrix 0, 1, 2, minus 5, minus 3, minus 7, 1, 0, 0, and then times what? It is a vector. Okay, so without wasting time, go to step 1. Step 1, before we can solve this system, there will be need for us to find the eigenvalue. That's the first thing to do. Step 1. Find what? Find the eigenvalues by using 0 equal to and this expression has a meaning. So let's first of all put the determinant equal to 0, and this expression in the brackets, it means the leading diagonal. You subtract r from that. R minus r minus r. And why other values remain the same, remain constant. So we now have minus here, negative r, 1, 2, minus 5, minus 3, minus r, minus 7, 1, 0, and then minus r. Okay, so we have used this equation now so that to be able to get what? The eigen value. And don't forget your r is what? Is the eigen values. Okay, so let's solve these determinants. When you're solving determinants, you check which one will be okay, which one will be faster. I could use row 1, the first row. I could also use row 2. But in this question, row 3 will be faster. The third row will be faster to do the evaluation. Why? Because of this 0 here. Okay? So I'm evaluating along this row. We'll cover this place vertical. We'll cover this place horizontal. Okay? So we have 1, and that will be determinant of the remaining one here. 1, 2, minus 3, minus r, then 7. Then this is 0 here. So we'll skip that place. We'll come back here also. Equal to 0. Okay? As I've said, for the first one, cover this one vertical, horizontal. Then you have these determinants. This is here. Then for the third one, cover it vertical, cover it horizontal. So we have this. Okay? So we now have this will multiply this one. So we have 1 times minus 7 minus 2 into brackets, minus 3 minus r. Okay? We close the brackets. Then minus this, put your brackets, this one times this one, so that is minus r times minus this, minus that, then this one times this, so that's minus, this is minus 5, making plus 5, equal to 0. So let's do the expansion. So this will be minus 7, this one times this one, that's a plus 6, this one times this one, and a plus 2r. Then here also minus this. Let's do the inner brackets. This one times this one, that's a 3r. This one times this one, plus r squared, and then plus 5 equal to 0. So that's what we have now. Minus 7 plus 6. That's minus 1 plus 2r. Then open this bracket here, so which will be equal to what? Minus 3r squared, and then this one times this one, that's a minus r cubed, okay, then minus 5r equal to 0. So that's what we have now. Then we can do the arrangements. We have minus r cubed followed by this 3r squared minus this plus this, that's minus 3r, okay, and then minus 1 equal to 0. So we can multiply all through by minus, and that will be this plus 3r plus 1 equal to 0. So this expression is the same thing as what? R plus 1 equal to 3 equal to 0. Okay? And if you don't know this one, just use your calculator and get the value. So that implies that R1 is equal to R2 is equal to R3. And that's equal to minus 1. Because the meaning of this to power 3 is, it implies, this one implies 3. Each of them, this is equal to 0, this is equal to 0, this is equal to 0, this is equal to 0. Okay? So, the eigenvalue now repeated, the eigenvalue is repeated three times. okay, which is equal to what? R1 equal to R2 equal to R3 minus 1. Next step, to get the eigenvector corresponding to R equal to minus 1. Okay, and by doing that, we're going to solve this system. So I'm going to call this one, this is the first eigenvector. Okay, and don't forget R is what? If you substitute for this, then you have this. And what is the meaning of this expression? The meaning of this expression is just go to your matrix, and then the leading diagonal add one to it. Plus 1 here, plus 1 here, plus 1 here. And other value remain the same. Other value remain constant. Okay, so we now have the first one plus 1, we have 1. Second one remain, does not change, 2, minus 5. Minus 3 plus 1, that's minus 2. And then minus 7, 1, 0, 1. Okay, so that's the meaning of this expression. And this one, the component of this one will be U1, U2, U3. Okay, equal to what? Equal to 0, 0, 0. The next thing to do now is to do the augmented matrix. Augmented matrix. Augmented matrix. And that will be combinations of this one and this one. So we now have 1, 1, 2, minus 5, minus 2, minus 7, 1, 0, 1. You put your line, okay, and then the equal values which are zeros. Okay, so that's the augmented matrix. Okay, so what we want to do now is to do the row operation, and what we are looking for is to have at least here, okay, 0, and if possible, all the elements here will be zeros. Okay, here also, at least in this third row, at least we have 0 here also. So how do we achieve our targets? Is to row 2 will be equal to, this is negative 5. So for you to make this to be 0, that means this one will be times 5. So we're going to have row 2 plus 5 row 1. Okay? Then the third row, row 3, this is 1, this is 1. So very easy, row 3 minus row 1. Okay? Then your reference point is row 1. It's not changing. Okay? So just have 1, 1, 2, put your 0 here. So this will be, this is minus 5 plus 5, that's 0. This one here times row 2 is this minus 2 plus what? Plus 5. We have 3 here. Here is minus 7. This one times 2 plus what? Plus 10. So I also have 3 here. So this one is 0. Then here, 1 minus 1, I have this. 0 minus this, minus 1. 1 minus 2, I have minus 1. 0 minus 0, I have 0 here. So, so that's what we have now. We can continue to do the evaluation straight away. And if you want, you can still try to reduce the everything here, all the elements here to be 0 if you want to. Okay? Choice is ours. And if you want to do the row operation again, you can use 2, either row 2 or row 1. Okay? So let's continue with this third row. So the third row, I want to make it to be all zeros. But it's not compulsory, it's not necessary, since I have already I have 0 here, 0 here, 0 here. Okay? The third row, I can have 3, row 3, plus what? Plus row 2. So this is 0. This is minus 3 plus 3, that's 0. This is minus 3 plus 3, that's 0 also. So this is what I have now. Okay? So I can go to I can use row 2 and row 1 to get eigenvector. From the second row, we have 3u2 plus 3u3 equal to 0, 0. So u2 now, 3 cancel, 3 cancel. So u2 is equal to what? Minus u3. Just note that. Note that. Then go to first row. So that will be u1 plus u2 and then plus 2u3. Okay? So what we do now is to make u1 the subject, and that will be what? Minus u2 minus 2u3. And that is what? And u2, I have the value for that, which is what? Negative u3 minus 2u3. So this will equal to a plus. Okay? So that's 1 minus 2. So minus u3. So that's u1. So what we do now is consider u3 to be x. Okay? So in that case now, the eigenvector, the first one, will be equal to u1 is what? That will be minus, this will equal to minus x. u2 is what? u2 is also minus x. And u3 is what? X. Okay, so that's what we have. Then you can factorize this and have minus 1, 1. Therefore, minus 1, 1 as a vector is what? Is the eigenvector for what? For r equal to what? Minus 1. Okay? Then the next thing to do now is to calculate generalize eigenvector u2 bar and what? u3 bar. Okay, so to calculate the generalized eigenvector for second one and for the third one. Okay, how do we do that? By for u2, for second one, for this, okay, I'm going to use this expression. Okay, so let us go back to our matrix. This is minus what? Minus 1. And don't forget your r is what? Your r is what? Minus 1. So if you put it here, you have what? You have this. Okay? So what's happened there? That will be you are adding 1 to the main diagonal, which we have said before, minus 2, minus 7. This is 1, 0, 1. So that's the meaning of this expression, a plus I. Then here, the component of this will be what? u1, u2, u3 equal to 0, 0, 0. Okay? So then the next thing you do now, your u1 here, this vector, the first eigenvalue, we have the value in this case. We have the value. So the value will be what? We have it as minus 1, minus 1, minus 1, 1. So that's the first eigenvalue. This is, okay, that's the first eigenvalue. So that's the value here. Okay? So so in this case, it's not 0, 0, 0. So we have the value for u1. Okay, so augmented matrix. So we have 1, 1, 2, minus 5, minus 2, minus 7, 1, 0, 1. Close that. So we are combining this one with this one. So that's minus 1, minus 1, 1. So row operation. And that will be equal to row 2 is equal to, this is minus 5. I want to make this to be 0. So this is times what? Times 5. Row 2 plus 5 to 1. What about row 3? Row 3 also will be what? Row 3, this is 1. And we want this to be, our target is to have this place to be 0. So that will be this minus this. Row 3 minus row 1. So we now have row 1 is the reference, this first row is a reference point, it's not changing. So this one, minus 5 plus 5, that's 0. Minus 2 plus 5, that's a 3. Here, minus 7 plus a 10, that's 3. Here, minus 1, okay, plus, this one is times 5, that's a minus 5, so this will be minus 6, okay, 1 minus 1, that's 0, 0 minus 1, that's minus 1, 1 minus 2, that's minus 1, 1 minus 1 minus minus 1, that's 2. So that's what we have there. That's 2. This row 3, we can turn it to zeros if we want. And if you want to do that, we can use either row 1 or 2 to form our expression. Okay? So the third row is equal to 3 row 3 plus row 2. So that's the only one we want to make amendments. So that 1 is not changing, 1, 1, 2, minus 1. Row 2 also is not changing, 3, 3, minus 6. So 0. So row 3, this one times 3 plus this one times 3 plus this. So that was 0, 0. So this one is times 3, that's 6 plus this, that's 0. Okay? So that's that. And if you want to do this, the second row operation, you can just pick either this one or this one to form your equation. Okay? So for the second row, we now have 3u2 plus 3u3 equal to minus 6. Okay? That's minus 6. So we now have 3u2 equal to minus 3u3 minus 6. So u2 is equal to what? Divide this by 3, divide by 3, divide by 3. So you have what? Minus u3 minus 2. Okay? So just note that equation. Just note that equation. Okay, then we go to first row, which will be u1 plus u2 plus this one 2u3 equal to minus 1. Okay, so u1, u2 has an expression which is a minus u3 minus 2, and then plus 2u3 equal to minus 1. So u1, open these brackets, minus u3 minus 2 plus 2u3 equal to minus 1. So we now have u1 is equal to, this is minus u3 plus what? Plus 2u3, that's u3. If you take it to the other side, you have minus u3. Okay, minus 1 is already here. Minus 1. Then you have minus 2 here. Move it to the other side, and then plus 2. So u1 is equal to minus u3. Minus 1 plus 2, and a plus 1. Okay? So let us consider u3 to be x. So the second eigenvector will be u1 is what? u1 is what? Minus x plus 1. u2 is also, u2 is there, minus what? Minus x minus 2. And then u3 is what? Is this. Okay? So that's what we have now. Take s as a 0. We now have u2 equal to 0 plus 1, that's 1 minus 2, that's 0. So that's the generalized eigenvector. The next thing to do now is to get the generalized eigenvector for the third one. Okay, so next, and by doing that, we solve this expression. That will be u3, so we are looking for equal to what? U2. Okay? And don't forget, this expression will be what? U3 equal to U2. Because your R is minus 1. Okay? So let's do that. So this will be equal to what? This expression mean your main diagonal will be plus 1, plus 1, plus 1. Okay? So that will be 1 here, 1, 2, minus 5, minus 2, minus 7, 1, 0, 1. Okay? Then the component of this vector will be what? U1, U2, and U3. Okay? Equal to what? Equal to U2, which is the value we just got here. And that was what? 1 minus 2, 0. Okay? So that's what we have now. Then the next thing is the augmented matrix. And that will be combinations of what? That will be 1, 1, 2, minus 5, minus 2, minus 7, 1, 0, 1. Then you put a line, a slash, a line, okay? And that will be 1, minus 2, 0. So that's the augmented matrix. Then let's do the row operation. Then this one is equal to 3 minus what? That's this one minus this. So we just have the first row is the reference point, it's not changing. So this is minus 5 plus 5, that's 0. Here is minus 2 here, plus 5, that's a 3. Here is minus 7, and then times this one times 5, that's a 10, so this is also 3. Here also is a minus 2 plus what? Plus 5. So this is also 3. 1 minus 1, that's 0 here. We have minus 1 here. And then we have minus 1 here. We have minus 1 here. Okay? What we do now, row 3, let's just make this third row to be all zeros. Okay? So I'll just solve second row and first row. So row 3 will be equal to 3 plus row 2. Second row will now become 3u2 plus 3u3 equal to 3. Okay? 3 is here, 3 is here, 3 is here. So we just have u2 equal to, this is 1, 1, okay, minus u3. So u1 will become, this first row, we now have u1 plus u2 plus 2u3 equal to 1. u1 is equal to 1 minus u2 minus 2u3. Just move this one to the other side. Move this one, shift this one to the other side. Okay? And that's equal to 1 minus u2 is 1 minus u3 minus this one. Consider u3 as this. Okay? So in that case now, this will be equal to what? Minus what? Minus this. And then this one will be equal to what? 1 minus what? 1 minus this. Okay? So the third eigenvector will be equal to U1, which is minus this, is 1 minus this, and then U3 is this. So this is what we have. Okay, then take what? Take x as what? As 0. So if you do that, we now have U3 equal to what? So this one, U3, as this is generalized eigenvector. Therefore, the solution the first solution will be equal to U1. We have it, or U1 is this one. That's minus 1, minus 1, 1 times what? Exponential to power minus t. Okay? The second solution is equal to, don't forget the formula, that will be U1, open your brackets, the vector, the first one, which is what? Minus 1, minus 1, 1. So it's ut, you put your t beside, then plus the second, the generalized eigenvector, which is this one here, that will be equal to what? 1, minus 2, 0, and then that's u1t plus u2, then you close it, exponential minus minus t. So that's the second solution. Solution is open your big brackets, and that will be equal to u1, which is this one, then t squared over 2 factorial, then plus the u2, which is this one, 1 minus 2, 0, times what? Times t, and plus the third one, which is the third eigenvector, which is 0, 0, 1, 0. Then you close your brackets, which you open here. Then you put your exponential minus t. The minus here is your eigenvalue times what? Is t. The general solution is that will be c1 times x1 plus c2 times x2 as a function of t, then plus c3 x3 as a function of t. And I want to tell you, when you are watching this video, you need your writing materials. When watching this video, you need to write. The more you do that, you write, you practice while watching the video, the more it sticks to the brain. Lest I forget, there is a link on this video. Please smash that link and subscribe. Okay? Type your comments and click on that like button. And finally, share this video on your social media platform. Okay? And the next video will be how to solve complex eigenvalue. So please join the next video for what? For solving complex eigenvalue. Okay? See you in the next video. Thank you.